Welcome back to another Explainer. Today, we're unpacking the compounding impacts of environmental pollution. Now, as people who follow this space closely, you know terms like emissions and climate change completely dominate the headlines. But today, we're actually visualizing the structural breakdown of these forces, really digging into how they're actively reshaping our reality.
At a foundational level, environmental degradation is driven by four primary vectors. We've got atmospheric pollution, which is largely driven by industrial and vehicular emissions, water contamination, stemming from agricultural runoff and industrial waste, soil degradation, characterized by mounting landfill mass, and of course, the pervasive and often totally overlooked impact of noise pollution, disrupting human and ecological baselines.
Here is our roadmap for today's Explainer. First, defining the problem. Second, the impacts of climate change. Third, managing the risks. And finally, a brief summary and review to wrap things up.
Let's get right into Section 1, defining the problem. What exactly are we facing?
So at its core, environmental pollution is just the introduction of harmful contaminants into our natural ecosystems. It's when harmful things dirty the air, water, or land. We're talking about the disruption of local biomes, whether that's through atmospheric smog or microplastics in our waterways, that fundamentally degrades the habitability of our environment. But while pollution often hits us locally, climate change represents a systemic, macro-level shift. This refers to long-term structural alterations in global weather patterns. It's the big-picture change driving severe meteorological anomalies and permanent ecosystem shifts all across the planet. Think of it this way. Pollution is immediate, localized contamination. It's like actively dumping waste into an enclosed space, like literally throwing garbage right into your room. Climate change, however, is the long-term atmospheric reaction to that ongoing contamination. It's the weather itself acting completely differently over time, fundamentally altering the conditions of the environment over decades. Moving on to Section 2, impacts of climate change, the real-world consequences. The stakes here are physical and honestly undeniable. We are witnessing a shockingly rapid transition from thriving, balanced ecosystems to severe resource depletion. The harsh contrast between a resilient, healthy hydrosphere and an arid, cracked, degraded Earth isn't just hypothetical anymore. It's the current trajectory of affected regions right now. Because of this environmental degradation, our most vital resources are directly threatened. We're seeing severe aquifer depletion where rivers are literally drying up, a massive loss of clean drinking water, and greatly accelerated soil erosion. And look, when topsoil degrades, agricultural yields absolutely plummet, crops just do not grow well, which poses an immediate critical threat to global food security. Furthermore, these shifts act as a massive threat multiplier for natural disasters. Changing weather patterns mean heavy precipitation events quickly turn into catastrophic flooding. We're seeing warmer ocean temperatures fuel increasingly stronger, more destructive storm systems and hurricanes that just completely devastate local infrastructure, homes, and roads.
All right, Section 3, managing the risks, from global to local actions.
So how do we actually fix it? Well, mitigation cascades across multiple levels of governance. It requires macro-level global agreements, like the Kyoto Protocol, to curb those industrial greenhouse gas emissions. That filters all the way down to regional legislation focused on protecting critical carbon sinks, like our forests, and ultimately relies on local, community-driven sustainability practices, down to things as local as school recycling programs. Which brings us to a real game changer: sustainable development. This is simply the practice of managing our current resource consumption in a way that does not harm the future. It requires proactive intervention today, like aggressively planting trees and saving water, to ensure we aren't compromising the ecological viability of future generations. It's all about building long-term environmental resilience. Bringing us to our final part, Section 4, summary and review, testing your knowledge. To easily synthesize all this information, we can frame our understanding around 5 core pillars using a really handy memory tip: CDWSR. That stands for climate, representing the long-term shifts; disasters, which are the resulting acute events; water and soil, representing the critical resources at risk; and finally, response, which defines our necessary sustainable action. Let's test your attention for a second based on that framework. How would you define environmental pollution now?
Remember, it's no longer just about visible smog or throwing garbage in a room. It's the systemic contamination of our ecosystems that serves as the catalyst for these much broader crises.
In thinking back to the real-world impacts, what is a clear example of a natural disaster caused by these shifts? Well, as we've seen, the drastic increase in severe flooding after heavy rains, or the stronger hurricanes tearing up infrastructure, serve as immediate, visible metrics of our changing climate. Ultimately, moving from the problem to the solution, what is one actionable way we can step up and protect our environment? As we discussed, it requires a multifaceted response. Whether it is through binding international protocols or highly localized conservation efforts, the defense of our biosphere requires coordinated action at every single tier of society.
By truly understanding the direct link between localized pollution and macro-level climate disruption, we are so much better equipped to implement systemic solutions. The power to lift our environment out of a polluted wasteland and ensure a healthy globe for the future is literally in our hands. The trajectory is dictated by the policies and practices we establish today. The knowledge and the frameworks completely exist. So the real question is, do we have the collective will to implement them before the damage becomes irreversible?